네, can you hear me? 잘 들리나요? 아, 네, 다행입니다. 네, 감사합니다. Thank you. Thank you for your response. So, okay. So now it's 3:30 p.m. So now it's time to start the first class of this course. This course name is Computer Architecture, and then course ID is COSE. I don't know how to pronounce it. So COSE 222 is a computer architecture course for undergraduate student. So I believe this course is a mandatory course in computer science and the computer engineering department. So this course is provided every semester. Yeah, so I also taught this course in the last semester. Then also this semester, I will teach this course also. So 잘 안 들리나요? So can you hear me? So someone said that she or he cannot hear me, but yeah. So I think it's a students the problem, not my issue. Okay. Yeah. So this is the real-time online course. So sometimes the unexpected problem happens. But so I try to ready for for this course, but sometimes unexpected problem happens. So okay, let's start. So this course is the computer architecture course for undergraduate student, and my name is Konjae Koo. I'm an assistant professor in the Department of Computer Science and Engineering. So okay, let's start. This is some introduction to this course. So, okay, let's think about the object of this course. So when you take some courses, then you need to know the object of a course. The object means the goal of this course. So I believe most of the students take this course because this course is a mandatory course. But so you need to actually invest your time and then your effort to this course for maybe better grade or your better knowledge on the computer systems. But if you take the course, then you need to know the goal of this course, the goal of the course, so object of the course. So what is the object of this course? The object of this course, I believe you already read the syllabus of the course, I hope, but yeah, so object of this course is exploring computer system architecture at an abstract level. So actually you need to focus on the word abstraction. So I believe most of students are sophomore level. That means it's a 2학년 the 2학년 of the university. So it's a sophomore level. So but someone knows the word abstraction, and then someone do not know the meaning of the abstraction. Actually, the abstraction is a very important term in computer engineering field. Then I will explain about the definition of abstraction later, but you need to focus on the abstraction level. So actually the object of this course is to explore the hardware aspect of computer systems. So actually the name of this course is a computer architecture. So in Korean is a computer 구조. So this this course is different from other some software level course because we will explore the world of computer hardware or computer systems. So when you talk about the computer science or computer engineering department, then the many people believe that the computer engineering student will learn about the what's the matter? Okay. So actually, I will also post this recorded video on the YouTube after this course. So if you cannot hear me, then you can play back the recorded video after this course. Sorry about the problem, but I think the problem is the problem of my side. I think it's the problem of your side actually. What's that? Is there another link to course join the throw? No, the Zoom link is is a unique link. Okay. Okay. Sorry for some problem. Yeah. So where should I continue? Okay. So many people think that if in the computer engineering department, the student learn about the programming and the software aspect of the some computer actually it's a computer not computer hardware, but in this course you will learn about some aspect of the computer hardware. So it's the computer architecture, and then the interface between hardware and software of computer systems. So actually this is very important. So someone think that as a computer science student we need to learn about how to program the some applications, but in order to write some better programming or better some application, actually as some computer engineering or computer science student, we need to understand how the computer systems work. It's very, very important because so actually the programming language is very similar to the language like English or Chinese, some languages. So actually, it's not easy to learn these foreign languages. I know, but even though we know about the language, but that means that that means that uh, uh, that that does not mean we can that means we can just use the language, but without this how to use the language, then we cannot do anything. So as a computer science student, you may, so actually the area of the computer science and engineering is very wide. So I don't know what's the goal of your career path as the computer engineering student, but even though you are interested in some computer software aspect of the computer science, then you need to learn about the computer hardware and then how the computer works, because it's essential to make the better software or better system software or better firmware or some better computer systems. So I said better software, better application, better system software, better firmware, better computer systems, or better computer hardware. So it's every aspect of the computer engineering department. So you need to understand how computer works. So basically, the computer architecture is the course to teach how the computer works. So, and then, so I think the instruction is somewhat long. So what will be covered in, let's see what will be covered in this course. So actually, so we will learn about the basic concept of computer systems, focusing on computer hardware. And then I said the interface between computer hardware and software. Okay, so what we covered, so detailed topics of this course will be performance metrics, then how to measure the performance of the computer systems, and then it's an important topic, instruction set architecture, or ISA. And then we will learn about some basic concept of a machine language. So actually this instruction set architecture is the interface between computer hardware and computer software. So if we say if we say about some computer software, then most of the people believe most of the people think that computer software is the programming language such as C, C++, Python, or some other languages. That languages are high-level language. That means these programming languages are very similar to our ordinary languages such as English. That's right. It's a human language. It's a human natural languages, but the computer systems can understand the human natural languages. So these high-level languages or high-level programming need to be translated into some signals or languages that the computer systems understand. So this language is called the machine language, and then the the instruction set architecture just defined how the computer instructions are defined, and then the operation of the computer hardware when the computer instruction is asserted to the computer hardware. That is the instruction set architecture. So that's so one of our important topics we will learn in this course. And then we will review the arithmetic logic and the number systems because the computer system, so actually the computer hardware is very similar to the calculator. So, so that means the computer hardware just handles some data, actually number data. That means we need to understand how the computer handles our number systems, such as integer or floating point numbers. But I believe if you took the the logic design course like a COSE221, I believe, then you will learn about these number systems, digital number systems. But so I mentioned this is the review of the number systems. So I will slightly review this topic during this course, so number system and arithmetic logic. And then another important topic is in-order processor architecture. And then in other words, it is called the pipelining. So I believe some students heard about the terminology pipelining, and then someone do not understand what is pipelining. But this is a very critical topic and a very important topic in the computer hardware and the computer architecture. So we will learn about how pipeline works in the computer processor, and then also we focus on the architecture of in-order processor. In-order processor, okay? So also you need to remember that this is also one of the very important topics in this course we will learn in this course, okay? And then another important topic. So actually every topic is important, but another important topic is memory hierarchy. I believe, so everyone knows about the memory system such as DRAM or SSD or HDD, hard disk drive. Also, we sometimes mention about the flash memory because most of the smartphone has used this flash memory as the storage devices. So, and then we already know about the definition of the memory system. So our data is stored in the memory. So we will learn about how memory systems work in the real computer systems. Also, this is the very important topic. So, and then we will slightly explore the parallel process architecture. So you need to remember that in this course, actually we will learn the three important topics. So the one is the instruction set architecture, ISA. And then the second important topic is pipelining in the process architecture. And then another important topic is memory hierarchy. So if you take this course, you need to understand what ISA is in computer systems, and then what the architecture of another processor and the pipelining and memory hierarchy. So you need to understand and you need to know, okay? Okay, so we will use this book as the textbook of this course. The name of the textbook is Computer Organization and Design and Risk 5 edition. Actually, in this course, we will learn about the Risk 5 instruction set architecture. So actually, the Risk 5 is the risk type ISA. So ISA is called ISA. Okay, so this is the instruction set architecture of the RISC-V processor. So this is a RISC type of processor, and then it's newly developed by the professors at UC Berkeley and Stanford University. So what is the most popular ISA in the computer system actually? So do you know? Yeah, right, x86. So sometimes we call the computer system is, so this computer is, my desktop is x86 computer. So that means this computer used the x86 instruction set architecture. How about our smartphones? So actually smartphones use most of the smartphones, but maybe I think it's 100% of the smartphones actually. So the most of smartphone processors use the ARM instruction set architecture. So I said that instruction set architecture is some protocol or promises between computer hardware and computer software. So based on this instruction set architecture, the computer hardware or computer processors are designed and it's manufactured. So instruction set architecture means, so different instruction set architecture means that the computer has some different protocols or some promises or protocols for the instructions that is executed in the computer system. But for this course, we will learn about the RISC-V ISA. This is the newly developed ISA. So that is a simple and more efficient than x86. And I think this RISC-V ISA is also more efficient than the ARM ISA. But x86 is also very complex. So the ARM ISA is a little bit complex, but RISC-V is simple and it's understandable and it's very efficient ISA, and then it's free. So that's why. So actually recently the researchers in academia and industry have high interest in the RISC-V ISA. So such as Samsung or Nvidia, is a big companies, and then some Western digital have interest in this RISC-V ISA because it's free. So we learn about the instruction set architecture of the RISC-V in this course. So you need to purchase this textbook for RISC-V edition. So computer organization and design RISC-V edition. And then for this course, I will provide the lecture slides. So I will post the lecture slides on the Blackboard and Piazza, and I will explain about the Piazza later. And then for lab assignment, we will use the model sim PE. What is P? It's a PE. So this model sim is the system Verilog simulator. So actually for the lab assignment, we will I plan to make student design the simple processor, simple pipeline processor with using system Verilog. So that means you need to verify your design using this verification tool or simulators. So this model sim is the verification tool and simulator for system Verilog. Okay, so we will use this model sim some pre-version for student, and then I will introduce some very simple architecture simulator for RISC-V ISAR. So this is the course materials and tools we will use in this course. It's okay? Okay, let's see the authors of this textbook. So actually this textbook is written by David Patterson and John Hennessy. So, so this photo shows the, I think is a John Hennessy and David Patterson. And actually they are very, one of the most famous computer architects. And then they invented RISC instruction set architecture. Actually, they are professors of UC Berkeley and Stanford University, and then they invented the RISC architecture with their graduate student. And then actually the most of modern computer systems use the RISC-like architecture. So you may think that x86 is the CISC architecture, but the inside of the Intel or AMD CPU also has the very similar architecture of the RISC architecture. So and this book is the computer organization and design is the classic book of the computer architecture course. So very famous, and then I believe many students learn about the computer architecture using this book. Okay, so I also learned the computer architecture with this book. So maybe, but the edition is low. So and then also this is another famous book in the computer architecture field. Is a computer architecture quantitative approach. So this is another famous book in the computer architecture, the advanced level. Okay, I also learned with this book also. So this is the recent photos of David Patterson and John Hennessy. Actually, they received the Turing Award in 2018. So actually, Turing Award is the most prominent award in the computer science field. So it is called the Nobel Prize in Computer Science and the Computer Engineering field. It is a Turing Award. So they received these Turing Awards in 2018, and then if someone receives the Turing Award, they need to provide the Turing lectures during the conferences, conference, and then they also made a presentation during the ISCA conference. The ISCA is the one of top tier computer architecture conference, and then also they provide the presentation during the ISCA conference. It's ISCA 2018. And then you can find this Turing lecture video here. So if you are into, it's a very great video, I think. So if you watch this video, then you can understand the history of computer systems, and then the recent research trend of the computer architecture and then computer systems. So if you are interested, please watch this Turing lecture video through this video link. Okay. So prerequisite is a recommended. So actually, I will give the lab several, maybe 4 lab assignments in this course, and then in the lab assignments, you need to design a very simple RISC-V processor. It's a pipeline processor using system Verilog. So that means you need to have the knowledge of digital logic design, which is provided in COSE 211, maybe digital logic design course. But I believe this is not a mandatory course. So I hope everyone took this course before taking this course, but it's not because it's not a mandatory course. Someone took this course, but someone did not take this digital logic design course. So that's the problem. But it's required for lab assignments. So I plan to provide some practice assignment for those who did not take this course. So if you did not take this digital logic design course, then please learn, please study on this digital logic design course by yourself. 독학하세요. 어쩔 수 없어요. Yeah. And then you need the basic knowledge on computer languages such as C languages, C or C++. But we will handle the C language. Actually, we will learn about the RISC-V assembly language, so assembly language and machine code. But this code is frequently actually we will provide some exemplar C code that is equivalent to the machine code. So I hope everyone can understand this very simple C code. So okay, so you need the basic knowledge on the programming language. So actually the C is I believe the C is more difficult than Python, and I believe everyone learned the Python first. But as a computer science or a computer engineering student, you need to understand the C language. C language is the basic language for computer software and computer hardware. Okay. Okay. I will introduce myself. So my name is Konjaku and Kugonje in Korean. And then my office is in Ujongjeongbogan 4-3. And then this is my no, it's not Monday. It's a Wednesday. My office hour is 1:30 p.m. to 3:30 Wednesday, not Monday. Sorry about the false information. And then this is my email address. So if you have any questions or any issues, then you can email me. Okay. And then, so my research area is the computer architecture generally. And then I have interest in GPU architecture and the memory storage systems and the embedded systems, accelerator or FPGA. So if you have interest in this computer architecture field, feel free to visit my office. Okay. So and then for the for course management, I will use the Blackboard. So Korean University Blackboard. So I will use this Blackboard for announcements and posting assignments. And then I will also post your scores, like exam scores and then assignment scores on the Blackboard. Also, I will post the lecture slides on the Blackboard. And then for some actually it's a second. So, and then for more efficient class management, I will use the Piazza tool. So actually the Blackboard is also a good tool, but it's not easy to use. So, and that's the problem. So I also create this course on the Piazza, and then this is the link of the Piazza, and then you can sign up Piazza with this access code. So you can use this CODE RISCV, so Computer Organization and Design Risk 5. Okay, COD Risk 5. So you can use this access code for signing up. And then please join as a student, not teaching assistant or instructor. So because you are a student, and then you can use this Piazza for discussion and then posting questions and then some for discussion. Or also I will post some course materials and then lecture slides and then lecture videos on the Piazza. It's actually a better tool than Blackboard. So it's a more convenient. And then this is important. Anyone can post questions and answers. And then also you can find the mobile apps of the Piazza and the Apple App Store or Google Play. So you can also use this mobile version of the Piazza. It's important. Anyone can post questions and answers. But normally teaching assistants and I post answers, and then but anyone, so any students. So if you know about the answer of the question, then you can post answers on the Piazza. And then so actually this is I think this is also important in as a student. So so actually the foreign students, like students in America actively participate in the discussion and this Q&A of the course, but in Korea, I believe so Koreans are shy, so they think it's not easy to post questions or post answers on this discussion tool or class management tool. But please be proactive on this class activities. Okay. So I captured the Piazza of the last Piazza of the last semester. So as you can see, students post the questions here, then you can find the instructor's answer. So you can post the questions in Korean, because using English is my duty, not your duty. So you can post questions in Korean or English. So I try to say any languages, but I can understand the other languages. So you can post the questions or answers in Korean and English. Okay. Okay. And then this is the grading policy. And then actually these are the fractions I used in the previous courses, in the previous course. So but it's not fixed fractions. So it's a tentative plan. And then attendances. So actually 30%, 40, and the assignment is 15. lab assignment 10, then attendance is 5%, and then pub quiz or online discussions. So I hope students can actively participate in the discussion or Q&A on the Piazza. But I admit that it's not easy. But I set the 5% of the entire score of this course as the attendance. So sometimes I will provide some question sets for the pub quizzes during the class. So I will use this score of the pub quiz as the attendance score. And then the Ministry of the Education forced professors to check the attendance of every class. So this is so actually in Korea University the attendance check is not it was not mandatory, but actually from this semester the government requires the strict check of the attendances in every class. So I believe so students need to register your your name and email address and student ID 학번 when you enter this Zoom. So with this information, I will check the attendance of the students. So you need to enter the exact correct student ID when you enter this Zoom link. So using this registration information, I will check the attendance of the student. 네, 그냥 한국어로 좀 말할게요. 뭐 대학생들에게 뭐 이렇게 어텐던스를 요구한다는 거가 좀 뭐라 그럴까 좀 이상하긴 한데 어쨌든 정부에서 거버먼트가 스트릭트하게 체크를 해라라고 이렇게 좀 내려왔기 때문에 여러분이 이제 줌으로 이제 들어올 때 so you need to register your name and student ID and email address when you enter the Zoom link. So I will use this information as the attendance of class. 출석으로 좀 체크를 하려고 합니다. 네. Okay. But the most important thing is the actually exams. So exam scores are most important. So and then the second important score is the assignment score. Okay, exam. So I plan the on-site exam. So 대면 시험이죠. I plan the on-site exam, but it depends on the situation of the Corona-19 pandemic. So recently the people are vaccinated. So people are actually are being taken the vaccines recently. So it started recently, but the problem is that the new COVID-19 patient is also increasing. That's the problem. So if the COVID-19 situation is not easy, then we can take the online exam. So actually, when you take the on-site exam, I plan the closed book exam. But if we take the online exam using Zoom and it's a lockdown browser, then it will be open book exam. Okay. 그래서 우리가 이제 대면 시험 볼 때는 closed book exam을 할 거고요. 대면 시험을 못 본다. 그러니까 우리가 이제 뭐랄까 그 온라인 exam을 봐야 된다. 그러면은 오픈북으로 합니다. 이거는 좀 기억을 해주세요. And then during the exam, no electric devices are allowed. Okay. And then it's very important. Any cheating may result in an F in this course. And you can answer in Korean or English during the exam. Okay. So I said using English is my duty, not your duty. So you can use any languages actually. You can use Korean or English because I cannot understand any other languages. Okay. So this is the tentative schedule of this course. You can find this schedule in the syllabus. So the May 5th, May 5 and May 19 is the national holidays. So the class will be canceled during the national holiday. Okay, this is the end of the syllabus. And then do you have any questions? 질문 있나요? Okay, let's move on other topics. The introduction to this course. Okay. Oh, what's that? Oh. This one. Okay. 질문 없나요? Do you have any questions? So you can post your questions in the chatting window, or you can use. Oh, there is no raise hand in this Zoom. Okay. Where is the PowerPoint slideshow? Okay. Okay, can you see this my PowerPoint slide screen? Oh, I cannot see chatting window. Where is the chatting window? Okay. Thank you. Okay. So let's start the first topic of this course. So is the first topic of this course is computer abstractions and technologies. So you can find the word abstractions here. So I said that abstraction is the important terminology in computer science and the computer engineering. So in the chapter one of this course, we will cover the computer abstractions and the technology trend in the computer hardware. Okay. Well, let's start. So let us remind the object of this course. The object of this course is exploring computer system architecture at an abstract level. So that means we will learn about computer systems. Then what does computer systems mean? So actually, I think everyone use computer systems every day and every time. So actually, we use our smartphone. Also, we use our laptop, computers. So actually, the computer is some basic devices we use in our life. So then, what is the computer systems? So I believe most of you already know the object called a computer because we use computer every time. And then what is this computer? This figure shows a first generation personal computer designed by IBM. So IBM, actually the IBM is the enterprise company recent nowadays, but IBM designed the first personal computer systems, but it looks ugly, right? And after some years, so other computer hardware vendor called Apple made fancier computer. So it's an Apple III computer. So it's a fancier than IBM's first personal computer systems. And then also Apple manufactured the better computer, better looking computer. So it's a fancier computer, much fancier, more beautiful computer system called Macintosh. So these are the typical figure of computer systems, of actually old computer systems, not recent computer systems. Okay, and then I think this is the recent some today's computer system. So actually sometimes the Apple, the computer hardware vendor, or nowadays is the also computer software company. Actually the computer hardware vendor called Apple designed the weird looking computers. So actually in the previous slide, this computer is, it looks somewhat ugly, whereas but it's some typical figure of the computer systems, but Apple's sometimes Apple create the weird looking computers, but I believe most of computer engineering students wants to buy these weird looking computers if affordable. 네, 좀 로망이긴 하죠. By the way, most of us always use computer systems everywhere. So I think I said everywhere. That means we use the computer systems or computer hardware every time and everywhere. So most of cellular phones are smartphones nowadays. So 뭐 핸드폰이라고 하는데 핸드폰이 아니라 셀룰러 폰이긴 하죠. So most of cellular phones are smartphones. Okay, so that means every smartphone has general purpose processors or CPU. So I said general purpose processors. So you need to understand the term general purpose processors. So that means we can run programs on these processors. Okay. So we can say that smartphone is a kind of computer systems. That is because the smartphone equips processors which can run general purpose application. That means any type of applications. And then how about the smartwatch? And then how about the smart speakers? These devices also include the computer processors, and then these devices can run software, that means general purpose applications. And then recently we are facing the different types of computer systems called domain specific processors. And then these type of computer processors cannot run general purpose applications. So it's so different from the general purpose processors. It's a domain specific computer, domain specific architecture, or domain specific processors. So on the other hand, these type of processors accelerate. So that means increase the performance of some specific domain applications such as machine learning or neural networks and graph processing. It's also some specific domain applications. So these processors accelerate the performance of specific domain applications. For example, this is the Google's, I cannot use, this is the Google's TensorFlow processor unit called the TPU. And then this TPU can boost the performance of neural network operations, neural network applications. And then this is the FPGA processor developed by Intel. So Intel also developed this FPGA type accelerator, and then we can program any some acceleration accelerator hardware on this FPGA, and then we can also increase the performance of some specific domain software, specific domain applications. And this is the GPU developed by NVIDIA. Recently the GPU is very expensive and very popular because of gaming. No, some other applications such as Bitcoin or machine learning, and then some other applications. So actually, traditionally we use this GPU for better gaming or image processing or video processing, but recently we use GPUs for some scientific applications or parallel applications, neural networks, machine learning, Bitcoin, cryptography, some other type of applications. But as you can see, the GPU also boosts the performance of parallel applications, not general purpose applications. So it's the new type of computer processors, and then recently many computer hardware vendors or researchers have focused on these domain-specific architectures. Okay, so new type of computers. And then what is this? What are these photos? So computer systems also include gigantic infrastructure of bunch of operations. So gigantic infrastructure. So what is this photo? This is the photo of Google's data center. So what is the data center? So in the data center includes the hundreds of many server computers, and then as you know, the size of the data center is very large. It's larger than the soccer stadium, and it's very large. That means very large. But we use data center as like a single computer actually. So I say for a single user, so this data center is very similar to the single computer. So we can call this data center infrastructure or cloud infrastructure as the computer systems. Okay, so recently cloud computing is very popular because of mobile devices or mobile computing systems. So and then so this data center infrastructure or some architecture of the data center is also the area of the computer architecture. Okay, so it's also some kinds of computer systems. So gigantic computer systems. So in conclusion, computer systems include all the systems or processors that can run programs. Okay, so that is called the computer system. If the device can run programs, this is the kind of computer systems. And then recently, most of electric devices run programs. That's why the most of the devices include the computer processors, and then actually most of the electric devices is similar to the computer systems. And Also, these devices are connected to data center or cloud infrastructure. So it's also network systems. It's connected to the other big size computer systems. So that's all computer systems, and then it's the area of the computer architecture. So we can say that these all devices are computer systems, and then the study on these hardware and then network or some other data center and then smartphone, also the personal computer and the computer processors, and then some other peripheral devices of the computer system. It's all included in the computer architecture studies. So computer architecture studies hardware of these computer systems. Also, the computer architecture studies the software for running computer systems. So what is such as the device drivers, operating systems, and or some firmware. So these are also the part of area of computer architecture study. And then computer architecture research focuses on better computer systems. So you need to remember better computer systems. What does that mean? Better computer systems. What are better computer systems? 뭐죠? 이거 촬영창이 오케이. What are better computer systems? 우리가 어떤 컴퓨터가 더 좋다고 얘기를 하죠? Actually, you need to remember. 계산 능력. So, actually, computation performance. So, in English, that means performance. That means the computer systems can run software faster, right? 더 빠르다고 얘기를 하죠. So we frequently say that this computer is faster than other computers. That means the performance of this computer is higher than other computers. That means this computer is better than other computers. So performance is the first goal of the computer architecture studies. Then the second goal, not the another goal is the cost. So what is the cost of the computer systems? Power consumption, and then some manufacturing cost, such as the so small area, so small size, and then low power consumption. So actually the computer systems require electric power to run the computer systems, because this is the electric devices. These are the electric devices. So that means computer consume power, electric power. So we need to reduce this cost of the power consumption on computer systems. So you need to remember that better computer systems mean high performance computers and low cost computers. 오케이? 그러니까 여러분들이 기억을 해야 돼요. High performance and low cost. How can we build these better computer systems? It's important. It's important. Okay. Why it doesn't work? Okay. So as we explored, there are different types of computers. That means different classes of computer systems, such as personal computers, such as our desktop or laptop computer systems. And then these personal computers can run general purpose applications. And then Actually, when we purchase these personal computer systems, the performance is also a critical factor. So we want the better computer. That means the higher performance. If the computer has higher performance, then we want to purchase these computer systems or this computer system. So, but for the personal use, we sometimes apply some trade-off of the cost and performance. And then also the another class of the computer system is server computers. So actually, these server computers has some high capacity, high performance, and reliability. Why? So personal computer is used by one person, where several people several people or families such as. But how about the server computers? Many people concurrently use server computers, and then these server computers are connected via computer network. So many users use the one computer hardware. That means this computer hardware support the high capacity or high performance, because many people use the computer resources concurrently, simultaneously. And then another important issue is the reliability. Reliability means that the output of the computer system is correct. So sometimes so you may think, oh, the output of a computer system is always correct, but it's not true, because sometimes the computer is broken, or the data is also changed by some other factors. So reliability is very important, because many people share this computer resources, and then also their important data is stored in these server computers. Okay. So sometimes it's the property of the personal computer and the server computer is somewhat different. Okay, and then supercomputers are used for scientific and then engineering calculation. So the most famous field that use the supercomputer is the weather forecasting. So the 기상청, weather forecast, the supercomputer is frequently used for weather forecasting. 기상청이 사용하죠. So because this type of application requires a very high performance, and then some massive parallel operation. So supercomputers are used for these some scientific field or some specific engineering field. Okay. Again, embedded computers. Embedded computers are used for mobile devices. So as you can see, we can think that this is the computer. This is a computer. It's a computer. It's a phone. How about this washing machines or TVs? And then we can think that these are called the consumer electric devices, like washing machines and TV systems. But computers are actually the computer processors are embedded in these systems, these devices, and then this type of computer is called the embedded computers. So that means people think that this is not a computer, but actually this is a computer, because the computer processor is hidden in such devices. Okay. Okay, so I will give us some computer architecture related questions. So before diving into the study of computer architecture, I will give some very simple questions related to computer architecture. So now you are looking at the two different computer processors, Intel Pentium 4 1.3, and then this Intel Pentium is the old generation of Intel CPU, and then the left side CPU here. So Intel Pentium processor used the 1.3 gigahertz of clock frequency. And then how about this computer? So I think you so this is the Raspberry Pi 3B, and then this Raspberry Pi works with the 1.2 gigahertz clock frequency. Okay, and then can you tell which processor is better? So I think I said better means higher performance. So in this case, so which computer system shows higher performance? How about the Intel Pentium 4 Raspberry Pi? So Intel. So we trust Intel. So yeah, because of higher frequency. But is it always true? Most of the people think that if the computer processor works with higher frequency, then it will have higher performance. It will show higher performance, and then that means the computer processor runs faster. But it's not true for every case. So so actually you will learn why the clock frequency is not a main factor of the performance. So we will learn about the performance of the computer system. So okay. So even though the Pentium 4 has the higher clock frequency, the Raspberry Pi can show higher performance because the architecture is different, ISI is different, also the compiler is different. So there are many factors that decide the performance of computer systems. Okay. How about this? Intel Xeon and Intel i7. Which processor is better? Xeon or i7? So Xeon processor is used for server computer systems, and then Intel i7 is used for personal computers. So which processor is better? Xeon or i7? So actually the answer is that it depends on application. Okay. So actually it's true that the Xeon processor is much more expensive than i7 processor because the Xeon processor is used for server computer systems. And then when I mentioned the server computers, then server computers are shared by many people and many users. So that means the server computers need to support the higher performance, higher capacity, and then higher reliability. So you may think that the Xeon processor is better than i7. That means the Xeon processor's performance is higher than i7 processor. But I can say that it depends on application. That means for a single thread of application, the performance of Xeon processor can be lower than the i7 processor. Okay. So we will learn about this in this course. Okay. How about this? Intel Xeon and NVIDIA Tesla. Which is better? Xeon or Tesla? So NVIDIA GPU. So which is more expensive? So more expensive is better. So recently the NVIDIA GPU is more expensive than Intel Xeon. But so the answer is also, it depends on application. So actually the Intel Xeon and NVIDIA Tesla has different architecture, and then actually Intel CPU and then NVIDIA GPU has a different architecture. So actually the NVIDIA GPU is good for specific domain applications. So we cannot compare the performance of these processors. Okay, it is called apple to apple. 그러니까는 우리가 이제 퍼포먼스를 비교할 때 1대1로 다 비교를 할 수는 없다. 이거를 좀 말을 하고 싶은 거예요. So we cannot we cannot simply compare the performance of the processors apple to apple. Okay. So you will learn why. So you will learn about the reason in this course. Okay. Okay. So actually the performance of a computer system is determined by many factors, like algorithm of the application and programming language, compiler, and architecture of the processors. Also the instruction set architecture can decide the performance of the computer systems. Also the processor or memory system can also decide the performance of a computer system. Also I/O devices such as network or input, some other devices such as keyboard, a person like a keyboard, can also determine the performance of a computer system. Okay, so we will also learn about these factors in this course. Okay, so that means computer system is not simple. It's actually it's not simple. So, but this is a very computer architecture is very interesting, and then even though it's not simple, and then it may be difficult for some people, but it's very fun and interesting. So I hope everyone can enjoy this course, and then everyone can earn some earn some knowledge on the computer hardware or computer architecture in this course. Okay, because the knowledge on computer architecture or computer system is very important. Okay, I will stop here. So do you have any questions? 질문 있나요? Okay, thank you for listening, and then see you in the next class. 수고하셨습니다.